Hi everyone, this is the Radical Tutor here explaining, and in this video we are going to look at differential equations. So what are these differential equations? So before we even look at what differential equations are, we are going to start by looking at the normal equations that we already know. So I can give you this equation to be 2x, so I can give you an equation to be 2x plus 4 is equal to 5. So this equation that I've written here is called just a normal equation that you already know. But now, if this equation is being replaced by a dy dx, then that equation is termed to be a differential equation. So for instance, if where there is x, we replace a dy dx, like let's say we say this is 2, where there is x here, we put dy dx, then plus 4 is equal to 5. This equation now becomes a differential equation because it has the dy dx in it. So any equation that will have dy dx in it is said to be a differential equation. Alright, having given that preamble, let's say a differential equation, so we can say a differential equation is any equation with dy dx in it. So any equation with a dy dx in it is said to be a differential equation. Alright, no wonder it is termed to be a differential, because whenever you hear the word differential, meaning we are looking at the dy dx or the derivative of a certain function. So any equation that will have dy dx in it is said to be a differential equation. Now there are so many types of differential equations that exist, but in this video we are only going to look at what we call as the linear differential equations. So let's look at what we call as the linear differential equations. So that's what we're going to look at today. So let's look at linear differential equations. Differential equations. All right. So this is what we are going to look at. So what are these linear differential equations? So linear differential equations are simple equations which are written in this form. So these are equations. So these are equations. These are equations written in the form dy over dx plus p of y is equal to q's of x. So any equation which is written in this form is said to be a linear differential equation. So whenever you have an equation which is written in this format, then just know that we are dealing with a linear differential equation. Alright, so we are going to look at how to solve these linear differential equations. Alright, having laid that foundation, let's have our first example and see how we can solve these linear differential equations. So our example that we are going to have is this one here. So this is our example. So example, we say solve this differential equation, or solve this linear differential equation. So solve, they will give you dy over dx plus 5y is equal to 4. So for us to solve this equation here, we need to know that this equation is a linear differential equation. Why is it a linear differential equation? It is a linear differential equation because it has this dy dx, which is there. Then it also have the 5y, which is also here. So meaning that p of y, meaning that we have a constant or a coefficient which is attached to y, which is corresponding to what is in our format there. And then this other side, we should have a function which is having x. So this function can either have x, or it can be a standalone function like the way we only have a 4 there. So this question is given in that format. That means it is a linear differential equation. Now the question is, how do we solve these linear differential equations? So to solve these linear differential equations, you should start by getting what we call as an integrated factor. So you should start by getting what we call as integrated factor. So you get what we call as integrated factor. Now, how do you get this integrated factor? Integrated factor is found by multiplying, is found by this formula, which is e to the power integral of p dx. So that's how you get integrated factor. So let's try to do that. So we say integrated factor is equal to e to the integral of p. What is our p? Our p in this case is the number which is attached to y according to our format there, because we are saying that p of y, meaning that the number which is attached to y is our p. So where there is p here, we put the number attached to y, which is a 5. So let's do that. So we put a 5 here and then the x, like that. And then this means we need to integrate that 5 with respect to x for us to be able to get its integral. So by doing so, we are going to say our integrated factor is equal to e to the integral 5. What is the integral 5? The integral 5 with respect to x is a 5x, because you know that integrating a constant is just a matter of adding the variable that you are integrating with respect to. So this becomes the integrated factor. That's how you get integrated factor. Now, after you've got an integrated factor, what we do is to simply multiply the integrated factor throughout the equation that you've been given. So this is the equation that you've been given, and you need to multiply this equation throughout with the integrated factor that you found. Alright, so by doing so, we are going to have this e to power 5x. So we first write our equation, which is this one, which happens to be the question. So we are going to write it as dy over dx plus 5y is equal to 4. But remember, we've already gotten our integrated factor, so we need to multiply this integrated factor throughout this equation. So by doing that, we are going to have our e to the power 5x. Okay, so let's multiply. So multiplying that, we are going to have e to the power 5x, or exponential 5x times dy dx. We are going to have e to the power 5x, or exponential 5x dy dx. And then we also multiply we are also going to multiply the e to power 5x times 5y. We are going to get plus e to power 5x 5y. And then we also multiply e to power 5x, or e exponential 5x times 5y. We get 5y e to power okay, that's what I've already done. I don't know if you've observed that. So I've already multiplied this to this. I've also multiplied this to this. So we also need to multiply this to that. So this means we are going to just put or include our equal sign, which is equal to, we also multiply e to power 5x times 4. We are going to get 4e. So we are going to get 4e to the power 5x. So now after we multiplied your integrated factor throughout the equation which was given, what you need to do is to integrate both sides of the equation. So you need to integrate both sides of the equation. How do you integrate both sides of the equation? You just need to introduce an integral this side. Also, you introduce another integral the other side, like that. So whenever you integrate this side of the equation, the answer that you always get is y with the integrated factor. So your integrated factor was e to power 5x, and I'm saying whenever you integrate this side of the equation, the answer is y e to the power 5x, which is y times your integrated factor that you get. Alright, so by doing that, you need to say this is equal to, you also need to integrate this side of the equation. So integrating this side of the equation, remember, these are basic concepts of integration, where you just need to differentiate the power there, which is 5x, you get a 5, and then it becomes 4 over 5 e to power 5x if we are to integrate this side. Alright, so that's what we're supposed to do. So now after you've integrated, it means you are done. What we're supposed to do is then to just make y the subject. How can we make y the subject? To make y the subject is simply to divide throughout by e to the power 5x. You also divide by e to the power 5x, like that. Okay, but please remember, before I even do that, maybe to make your work easier or your job easier, what we can do is to add a constant of integration. Remember, whenever you integrate, you need to add plus c, meaning that a constant of integration. So after that, that's when you can now make y the subject of the formula. So to make y the subject of the formula, what you can simply do is to divide throughout by the e to power 5x, so that you remain with y this side. So by doing so, we are going to say over e to power 5x over e to power 5x and over e to power 5x. And after you've done that, you're going to realize that this and that will go, and then we are going to remain with y is equal to 4 over 5. Now, it must interest you to note that whenever you are dividing, functions of the same base, here you have e to power 5x, here also you have e to power 5x. So you are dividing functions of the same base. So if you are dividing functions of the same base, what we are supposed to do is to simply just subtract the powers. So subtracting the powers, you are going to have e, we are going to have, let me show you. So this is e to the power 5x minus 5x, because we are subtracting these functions having the same base. So we say plus c over e to the power 5x. Alright, so from there what we can do then is to say our final answer will be y is equal to 4 over 5. 5x minus 5x is a 0. We are going to remain with e to power 0. Any number power 0 is a 0, so this will cancel out. And then we'll only have this to the power 0 is 1. 1 times 4 over 5 is this 4 over 5 here. And then plus, so plus the c over e to power 5x. So that means this becomes our final answer if we are to integrate, or if we are to solve this differential equation that we are given here. So basically these are linear differential equations, and that's how you are supposed to go about them. This is a Radical Tutor. Please don't forget to follow my Facebook page, and also go and subscribe to my YouTube channel for more tutorials.